Here is my video lab report on the extraction of an organic acid, base, and neutral. The topics I will be discussing include the materials I used for the experiment, safety and disposal, a brief intro to extraction, my procedures for extracting the acid, base, and neutral, and finally, the results I received at the end of the experiment. The chemicals used in the experiment were diethyl ether, which was used to dissolve the unknown mixture, 5 and 10% aqueous hydrochloric acid. I also used 5 and 10% sodium hydroxide and sodium sulfate as the drying agent to extract the neutral component. Other materials I used for the experiment include a centrifuge tube along with a stopper, a Hirsch funnel, a beaker, some Pasteur pipettes, litmus paper, a hot plate, and a few Erlenmeyer flasks. So the following experiment focuses on the extraction of an acid, base, and neutral component from an unknown. But what is extraction? Extraction is a way to purify substances in a mixture based on their chemical properties. And by manipulating the solubility of these three components, they can each be extracted, then identified by their melting points. For the first part of the experiment, we're going to see if our unknown contains a base. Since our unknown is organic, it will not be able to be dissolved in water. So a less polar solvent, in our case ether, is used to dissolve the unknown. After dissolving the unknown in 2 milliliters of diethyl ether, 3 1 milliliter portions of 5% hydrochloric acid are added to the solution. When the hydrochloric acid is added to the solution, the organic base accepts the protons when the chemicals react, moving the organic base from the ether layer to the aqueous layer. Because the hydrochloric acid has a lower density than the ether, the two liquids separate, allowing the hydrochloric acid layer to be removed from the centrifuge tube, then transferred to another test tube. To confirm the presence of a base, 10% sodium hydroxide solution is added to the extracted layers of hydrochloric acid. When the sodium hydroxide is introduced, the base loses its protons, making it insoluble and forming a precipitate. Next is the acid extraction, which uses a technique similar to the base extraction. To extract the acid, which is still in our original ether solution, we treat it with 3 1 milliliter portions of 5% sodium hydroxide solution. When the sodium hydroxide is added, the acidic component loses protons and becomes an ionic salt, moving it from the ether to the aqueous layer. Once extracted from the ether solution, the conformation of an acidic component is made with the addition of 10% hydrochloric acid. The hydrochloric acid gives protons back to the organic acid, making it insoluble in the aqueous layer, forming a precipitate. The last part of our extraction is the neutral component. Since the neutral has neither acidic or basic properties, it remains dissolved in the original ether solution, and a different technique is used to extract it. To extract the neutral component, we want to evaporate the ether in the solution so that nothing but our neutral is left behind. To make this possible, we need to get rid of any water that may be in the solution. We begin with transferring the ether solution to an Erlenmeyer flask. After the transfer, sodium sulfate is added to the flask to dry the solution. What the sodium sulfate does is absorb any water that may be left behind, making the evaporation process quicker. To evaporate the ether, the flask is placed in a steam bath so the ether is able to heat up slowly to evaporate without boiling too quickly and possibly causing a fire. Once the ether has evaporated, we can now collect the neutral component. Here are my results from the experiment. As you can see, I did not have a base in my unknown since there isn't a presence of a precipitate, but I did extract an acid and a neutral. After extracting my acid and neutral, the final step was identifying each component. To do so, we had to find their melting points. The melting point for my acid ranged between 100 and 104 degrees Celsius, leaving me to choose between O-anisic acid and O-tauloic acid based on a chart given by my instructor. Unfortunately, I was unable to find the melting point of my neutral. This error most likely came from my neutral being contaminated with some sodium sulfate that was not filtered out, therefore altering my results. Upon completion of the experiment, my instructor identified my unknowns as O-tauloic acid and fluorine.